Welcome back, guys. This is Ashwin. In this video, we are going to solve the problem Castle on the Grid. You are given a square grid with some cells open and some blocked. Your playing piece can move along any row or column until it reaches the edge of the grid or a block cell. Given a grid, a start and an end position, determine the number of moves it will take to get to the end position. For example, you are given a grid with sides 3 described as follows. So this is a 3 cross 3 grid. Only one cell is blocked. Your starting position is start x and start y, that is 0, 0. So this will change accordingly. So you can start in the top left corner. The ending position is goal of x, goal of y, that is 1, 2. So 1, 2 is this position. So the path is 0, 0, 0, 2, 1, 2. It takes 2 moves to get to the goal. That means the path will go from left to right and from top to bottom. It will take 2 moves. Like this, we need to find the minimum number of moves that it takes to reach the goal. So here we will be storing each possible scenario for the cells in the grid. So we will be storing each cell with the moves that it taken to reach that cell. Like that, we will be processing using the queues. So we will pop out in the front and check whether that point is the goal point or not. If it reaches the goal means we will return the number of moves, or else we will move on to the next cell. Like this, it will keep on going. It is also similar to graph problem. We will find the minimum number of moves like in BFS or DFS. Here we are using queues for that. This is almost similar to BFS if you know the graph concept. Okay, let's see the constraints now. Here n can go up to 100, so we can expect a maximum of 100 cross 100 grid, and the start goal and the end goal will be in the range of 0 to n. So we don't need to worry about the constraints here. Still, the exploration path is maximum, so we need to optimize the solution properly. Let's see an example. Here we have 3 cross 3 grid. The start position is 0, 0, that is the top left corner, and the end position is 0, 2. So that is the top right position. So reach this goal, we will go from top to bottom, left to right, and again bottom to top. So it's taking 3 moves to reach the destination. Here is the path that one could follow in order to reach the destination in 3 moves. That is the steps I have said before. And also here a step can be considered as a whole path, like a rook is traversing in the chessboard. So we can also stop here and move left. That is also one move. Or you can traverse the entire row or column. That is also one move. So these moves are almost similar to rooks in the chessboard. So don't mistakenly understand that each cell is considered as a one move. So that's a common misassumption. Okay, let's solve the problem now. Before solving the problem, we need to import a module from collections, import dq. So this is the queue data structure that we are going to implement. Now we need to initialize some variables. So c equals 0. So this is the number of moves we are going to calculate. So initially it will be 0, that is the start position, and visit equals a set. So in graphs, you will be seeing a concept like a cell is visited or not. So we will be storing the coordinates in the set and check whether the coordinates is already visited or not. It will be useful for avoid some extra processing. After that, we need to initialize q. Q equals dq of a list and again a list. In this list, we need to set the coordinates and the number of moves. So we will be starting with start x, start x, start y, and the number of moves. Initially it is 0, so I'm just using C. Okay, and the last one is moves. So from the current cell, we can move in 4 direction: top, bottom, left, and right. So we will be using a coordinates for incrementation. Moves equals a list, again a list. First, we will go in a vertical manner, that is top and bottom. 1, 0 and -1, 0. This is top and bottom and in the horizontal manner. So 0, 1 and 0, -1. Make sure you follow this order because sometimes if the order is changed means like shuffling this will result in wrong answer. So always remember you need to start in a vertical manner and after that go for horizontal manner. Okay, we can go for a main logic. So main logic while queue, that means if the queue is not empty, we will pop the front element of the queue. So that will be path X, path Y and C equals queue dot pop left. So this will pop the element in front of the queue and after that increment C by 1. C plus equals 1 because we are going for the next move. That's why we are incrementing C plus equals 1. Now we are going to traverse in 4 possible directions. So we can iterate using the moves list. So for xi, yi, these are the increments from moves. Now x, y equals path x, path y. I'm using a separate variable because each time we are going to increment some value. So if you are moving in top direction means in the next loop, we need to start from the same cell again. That's why I'm initializing a temporary variable like this instead of changing in path x and path y. Now in the while loop, while true x, y equals x plus xi, that is the increment, y plus yi. After incrementing these values, we need to check for the condition. Check the condition. We need to check whether this cell is in the range or not. So let's go down a little and expand this. If 0 less than or equal to x less than length of grid and 0 less than or equals y and less than length of grid 0. This is the number of rows. This is the number of columns. And the last one is we need to check whether the cell can be placed or not. That will be grid of x and y equals dot. If it satisfies all the conditions means we will execute the following statements. First, we need to check whether we have reached the goal or not. So if x equals goal x and y equals goal y, return C. So if the cell is reached the goal means we will just return the number of moves that it taken to reach the cell. If we didn't reach the goal means elif x, y not in visit. If the cell is not visited, we will just add the cells to the visit set. Visit dot add x, y. So we are just adding the coordinates to visited set. And after that, we need to add the coordinates to the queue. Queue dot append a list x, y, c. So these are the coordinates and the number of moves it taken. If the main condition is not satisfied in the else part, we will just break the loop. So if one direction is breaked means we will move on to the next direction. Like this, the process goes on. Finally, if we didn't reach the goal means we will return -1. That's the whole logic of our problem. First, we are initializing a variables for the number of moves and the visited set, queue for processing each cell, and we are initializing a moves list for incrementation of the coordinates. And while the queue is not empty, we are popping the front of the queue and increment the move by 1, and we are processing all the directions in the moves, that is top, down, and left and right. So we are incrementing each cell and check whether it satisfies the condition. If it satisfies the condition, again, we will check whether we have reached the goal or not. If we have reached the goal, we will return the number of moves it has taken, or else we will check if the cells is not visited. If it's not visited, we will add the coordinates to the visited set and append the coordinates to the queue. If the main condition is not satisfied means we will break the loop and move on to the next direction. After all the processing is done, we are not reached the goal means we will return -1. If you have any other logic other than this, please leave a comment below. It will be very useful for everyone. Let's run the code now. It passed the sample test case. Let's submit it. Yeah, we solved the problem. If you like this video, hit the like button and don't forget to subscribe the channel for future videos. See you guys with a new problem.